This is WAEC June 2019 General Mathematics Paper 2, and we are answering question number 6A. The question says that the force of attraction F between the two bodies varies directly as the product of their masses m1 and m2, and the same force varies inversely as the square of the distance d between them, that is between the two bodies. So given that the force F is 20 Newton, when the mass m1 is 25 kilogram and the mass m2 is 10 kilogram and the distance d is 5 meters. The question asked is to find Roman 1 an expression for F, that is the force in terms of m1, m2, and d. And Roman 2, you asked to find the distance d when the force F is 30 Newton, M1 is 7.5 kilogram, and M2 is 4 kilogram. So let's attempt to answer the question together. And this is a variation question. So going back to the statement, the force is what is mentioned first, and is this force that varies directly as the product of the two masses. So let's change this very statement into mathematical symbol. So you have F for the force and you have M1, M2 for the two masses. It is that force that varies directly as the product of the two masses. So changing that statement into mathematical symbol, you have something like this: F sign of proportion, then you have the product of the two masses by this right of the side of the proportion. If I go back to the question again, the same force F varies inversely, but this time around as the square of the distance d. The distance d is the distance between the two bodies. So the same F also varies, but this time around inversely as the square of the distance, and that distance is denoted by letter d. So you have F also sign of proportion, then 1 over, this is how we write if it is inverse proportion, and it is inverse to the square of d, so you have d square. So as this is the same F varies directly as M1, M2, and it is the same F that varies inversely as this d square, you can now merge these two to have F side of proportion, then M1, M2 as your numerator, and the d square as your denominator. So this becomes a joint variation. Let's just remove this side of proportion. There we usually introduce the constant of the variation. So you have F equals to, you have removed this side of proportion, you replace it by equality sign. That makes us always to introduce this letter K as the constant of the proportion. So you have F equals to K M1 M2 all over D square. So go back to the question. This F is 20 Newton when M1 is 25 and M2 is 10 and the D is 5. So you now substitute in this very formula so that you now get this constant of the proportion. So substitute F by 20, M1 by 25 and M2 by 10, D by 5 in this very formula. You now have 20 equals to K multiplied by 25 multiplied by 10 all over 5 square. So 25 times 10 is nothing but 250, and this 5 square is 25. So you have 20 equals to 250K all over 25. This 250 can be divided by 25 to get a 10. So you have 20 equals to 10K. To get a K, you divide both sides by its coefficient, which is 10. So dividing both sides by 10, you now have K as the 2. This is the constant of this very proportion. Now we can answer question number Roman 1 that we asked to write the expression or formula for this F in terms of M1, M2, and D. So what we simply do is to go back to this very formula, replace this very key, that is the constant of the proportion, which I have just obtained here as 2. Substitute K by 2 in this very formula. What you now have is the expression for F in terms of M1, M2, and D. So let's do that. So you now have F equals to K replaced by this 2. You have F equals to 2 times M1, M2 all over D square. So this is the expression in Roman 1. So we move to Roman 2. Roman 2, we asked to find the distance, the D, when F is 30 M1 is 7.5 and M2 is 4. So we are making use of this very formula to find whatever among these variables that we asked to find. So substituting F by 30, M1 by 7.5, M2 by 4, and in attempting to get this D, you now have 30 equals to 2, the constant E, multiplied by M1, which is 7.5, multiplied by M2, which is 4, all over D square. So next you cross multiply. That is 2 multiplied by 7.5 multiplied by 4 times the one here under this, the 30, and this 30 times the D square. So there you now have 30 D square equals to 60. 60 is 2 times 7.5 times 4. So you divide both sides by the coefficient of D square, which is 30. So you have D square to be equals to 60 divided by 30. It gives you 2. So to get a D, not a D square, you take square root of both sides. So taking square root of both sides, you now have D equals to root 2. So this would now be the value of D, that is the distance between the two bodies when the force is 30 Newton and the mass M1 is 7.5 and the mass M2 is 4 kilogram. So that answered all the two questions. So let me just share with you the mark distribution for this very question as it is contained in the marking scheme. So the very first mark is bonus 1 mark. And this bonus 1 mark is for writing F equals to KM1M2 all over D square correctly. You have this bonus 1 mark. Next mark is method 1 mark, and this method 1 mark, you have it when you now substitute correctly the F, the M1, the M2, and the D in attempting to get the constant of proportion. You have this method 1 mark. And when you now simplify up to the end to get the constant of proportion exactly to, you have this accuracy 1 mark. And the next mark is another accuracy 1 mark for writing correct expression or correct formula for F in terms of M1, M2, and the D as F equals to 2M1, M2 all over D square. When that is written correctly, you have this accuracy 1 mark. Next mark is method 1 mark in attempt to get a D when F is 30, M1 is 7.5, M2 is 4. In the formula, substituting those values correctly, you have this method 1 mark. When you now cross multiply in attempt to get your D, you have this method 1 mark. When you now divide both sides and take square root of both sides, you have this method 1 mark. And when you now have your D exactly as root 2, you have this accuracy 1 mark. So this question number 6A has 8 good marks.